All right, now that we're in expressions and equations and we're looking at inequalities, we just want to review what solving one and two step inequalities looks like and also how it's going to appear on a number line. As we look at this inequality, 4 is less than x minus 6. Simple solution to that is the same things that steps that we took to solving one-step equations. If this were an equation right here instead of an inequality, same thing that we do is we would isolate that variable by adding 6 to both sides and always looking to cancel something out. So we have 4 plus 6, 10, which is less than x. Now if we were to graph this, that's the next step, what we would do is we would find 10 on our graph. I'll just label a few points of these, 9, 8, 7, 6. And then we would say, well, if I put in a number 4x, let's just say 11. If I put in 11 and said, is 11 greater than 10? Yes, that's true. That is one of our points. As well as 12, 13, all of these are greater than x. But the one thing that I just want you to understand is when we graph these, we're going to have that open dot at 10, and we've talked about that open dot at 10, and we're pointing an arrow to all of the solutions that will work. Now, there's an open dot at 10 because, well, 10 won't work, and that's what that open dot signifies. But if it were a filled-in dot, then that's saying, yes, that's part of the solution. Let's look at our next problem. Same thing, again, that we're going to do with the one-step equations. For this one, if this were an equal sign instead of the inequality, what we would do is we would divide both sides by 3, because technically that's 3 times x. Canceling that out, leaving us with x over on the right side and 7 over on the left side. So I'm looking for any solution that will give me something less than 7. So I'm going to find 7 on my number line. And here we go. We are going to have an open dot because it's just less than. An open dot at 7. And let's put in some numbers there. 6, was 6 less than 7? Yeah. So that's the way our arrow is going to point. Alright, two-step, I'll just go through this quickly. First thing that we have to do, we're not going to mess with this yet. We're not going to mess with the 2x. What I want to mess with is the 6. So I'm going to subtract 6 from both sides. So that cancels out. 22 minus 6, that's going to give me 16. So 16 is greater than or equal to 2x. And now I can divide both sides by 2. This is just a review from two-step equations. Finding that cancels out, and that leaves us with x is greater than or equal to 8. So will 8 be a solution in here? You bet your buttons. I don't know where that phrase came from, but it's an idiom, not an idiot, an idiom. You can look it up. But x is less than or equal to 8. Well, it can be equal. That's why we're going to have a closed dot at 8, right above 8. Now let's throw in some numbers here. 9. Would 9 work for this? Is 9 less than or equal to 8? No. Is 7 less than or equal to 8? You bet those buttons. And that's why we're going to have an arrow pointed that way. Last example. We're subtracting 5 from this and from this side. Remember, it always wants to be right underneath whatever you're subtracting, multiplying, adding, dividing, whatever that is. And then do it to the other side. So we're left with x divided by 3 is greater than or equal to 10. To get rid of that divided by 3, we multiply by 3. Do not put an x as your multiplication symbol. You're going to confuse it with a variable then. Cancels out. Remember, every single step we want to cancel something out. And 10 times 3 is a weird looking 30. So x is greater than or equal to 30. I'm going to put 30 way down here. 32, 33, 34, 35, 29, 28, 27. All right, so here we go. We have a closed dot because that is greater than or equal to. So I'm going to look for all of my numbers that are greater than or equal to 30. 31 is greater than or equal to, 32 is greater than or equal to, 33 is also greater than or equal to, and that's why that line is pointed that way. So ladies and gentlemen, just a little bit of review. Watch it over if you want to. Otherwise, you now have the skills. You can firmly say that you can solve 1- and 2-step inequalities. Have an absolutely wonderful day.